Hello, everybody, and welcome back to another video in Geography 340 Climatology. I'm Dr. Zach Hilgendorf, and today we're going to be talking about major cloud types. So it's kind of coming off the last discussions we had on diabatic and adiabatic processes, and then following that on air parcels and frontal movement. So we've looked at what causes air to rise, what causes things to condense, and what causes the atmosphere to be stable or unstable. In this video, we're going to be looking at the different types of clouds that result from these processes at different points in the atmosphere. So clouds are based on how they appear when viewed from the Earth's surface. There are three basic forms. We've got first, cirrus or cirriform clouds. They're high, white, and thin. They form delicate veil-like patches or wisp-like strands, and often they look quite feathery, as we can see at that top one there, the cirrus or CI clouds. Stratus or stratiform clouds consist of sheets or layers that cover much of or the entire sky. Although they may be minor, or there may be minor breaks in the layers, there are no distinct individual cloud units. These typically form when the atmosphere is stable. After this, we have cumulus or cumuliform clouds. These consist of these globular cloud masses, we could call it, that look like cotton balls or sheep in the sky. Normally, they exhibit a flat base and appear as rising domes or towers. They form within a layer of the atmosphere where there is some instability leading to convection and rising air, and that's the really important part here. Additionally, the term nimbus, which is Latin for violent rain, is used to name in the name of a cloud that is a major producer of precipitation. Moving into height distinctions next, we first have our low clouds. These form near the surface up to a height of about 2,000 meters and are generally composed of water droplets, except during winter when obviously ice crystals prevail. Middle clouds occupy the heights from about 2,000 to 6,000 meters and may be composed of water droplets and ice. And then finally, we've got our high clouds forming in the highest and coldest regions of our troposphere, and normally have bases or cloud bases above 6,000 meters. These are generally composed of ice crystals or super cooled water droplets. And we can see here just kind of a description of them, or a brief description of each of the different cloud types. And we're first going to focus on these here, these clouds with vertical development. These are our cumulus or cumulonimbus clouds. These may extend through much of the atmosphere, as we saw in that previous diagram. So these are what we call cumulus-humulus clouds, or fair weather clouds is another one. It makes sense. We see these clouds, we think of kind of these beautiful summer afternoons, right, where conditions are pretty stable, not much is going on, we can enjoy and watch as the cloud goes by, and we try to see that maybe that cloud in the top left of that bottom picture is a duck, maybe, I don't know. It's nice though. Beside the point. These are a species of cumulus clouds characterized by small vertical development, uniform flat bases, and a general similarity amongst the clouds. Its vertical growth is usually restricted by the existence of a temperature inversion in the atmosphere. This, in turn, explains the unusually uniform height of the cloud tops of this cumulus species. A single cloud element that is able to penetrate the inversion may develop into a cumulus congestus cloud, or even further to become a cumulonimbus cloud. As in all species of cumulus, wind shear with height may give rise to a hard appearance upshear, where cloud erosion in dry environment air is taking place, and a fuzzy appearance downshear. This species is unique to the genus Cumulus. Moving on to these, as I mentioned before, these are our cumulus congestus clouds. So these have kind of broken through that inversion layer and are developing further. So this strongly spouting cumulus species with generally sharp outlines and sometimes with great vertical development, it is characterized by its cauliflower or tower aspect of large size. Mainly in the tropics, cumulus congestus may produce abundant precipitation. It may also occur in the form of very high towers, the tops of which are formed of a kind of cloudy puffs that, detaching themselves successfully from the main portion of the cloud, are carried away by the wind. then disappear more or less rapidly, sometimes producing something called virgo, which we'll talk about in the next video. Cumulus congestus is the result of the development of cumulus mediocris, another type of cloud, and sometimes of that of altocumulus clouds or stratocumulus clouds. Cumulus congestus often transforms into cumulonimbus. This transformation is revealed by the smooth, fibrous, often striated aspect assumed by the upper portion of the clouds. The species congestus is unique to the genus Cumulus. You see that here as well. Here, this is what we call a cumulonimbus cavus cloud. This is another species of cumulonimbus that evolves from Cumulus congestus. The protuberances of its upper portion, the protuberances of its upper portion have begun to lose their cumuliform outline. They loom and often flatten, then transform into whitish mass with more or less diffuse outlines and vertical striations. Cirriform clouds are not present, but the transformation into ice crystals often precedes this with great rapidity. Most often, this cloud is accompanied by showers. By convention, the name cumulonimbus cavus is given to any highly developed cumuliform cloud that produces lightning, thunder, or hail. Although the top shows no obvious trace of transformation into ice, the species cavus is unique to the genus Cumulonimbus. So here, kind of what we talked before, notice the wispiness at the tops of these clouds. It almost looks diffuse. The transformation of cloud particles from supercooled water drops to ice is described as having a glaciated upper portion, which is what we're seeing here. As that vertical development occurs, you're seeing kind of the wispier natures, that ice crystals rather than water vapor. Here, this is a species of cumulonimbus cloud called cumulonimbus capillatus. It's characterized by the presence, mostly in the upper portion, of distinct cirriform parts, frequently in the form of an anvil or incus, a plume, or a vast and more or less disorderly mass of hair. That's kind of how these are often described. So this cloud is usually accompanied by a shower or thunderstorm, often by a squall, and sometimes by hail. It generally produces very apparent virga. Again, we'll get into that in the next video. The species capillatus is unique to the genus Cumulonimbus. Here is almost a perfect example of our anvil. This is Cumulonimbus incus, or incus is Latin for anvil. It's also known as an anvil cloud. It's a cumulonimbus cloud which has reached some level of stratospheric stability and has formed a characteristic flat anvil top shape. It signifies the thunderstorm in its mature stage succeeding the cumulonimbus cavus stage. Cumulonimbus incus is a subform of Cumulonimbus capillatus. We can see another example of Cumulonimbus incus here. Here, this is what we would call mammatus clouds. So these basically protuberances look like pouches, more or less, on the undersides of clouds. The supplementary cloud feature occurs mostly with cirrus, cirrocumulus, altocumulus, altostratus, or stratocumulus, and cumulonimbus clouds. In the case of cumulonimbus, the mammatus or mamma generally appear on the underside of the anvil or incus. Get back here. Next, we're going to focus on our low clouds. So here we see stratus clouds. Stratus clouds form in low horizontal layers that, on occasion, may produce light drizzle or mist. They are white to light gray and have very uniform bases and appear to blanket the entire sky. Nimbostratus derive their name from Latin nimbus, meaning rain cloud, while stratus means to cover with a layer. These tend to produce constant precipitation and low visibility, forming in stable conditions when air is forced to rise, as would be along a front. See another example of that here. Here's our nimbostratus clouds. This type of forced ascent of air leads to the formation of a stratified cloud deck. that is widespread and may grow in the middle level of the troposphere. Think of these clouds as the ones that produce our very long, consistent drizzles. Here, these are what we would call our stratocumulus clouds. These consist of broken patches of clouds that are generally much larger than those of our altostratus clouds. They often cover vast stretches of the subtropical oceans, providing a ready supply of surface moisture. They're also incredibly important because they reflect considerable amounts of incoming solar radiation. We can see them here and here as well. Next, go up to our middle clouds, our heights between 2,000 and 6,000 meters. Here we see our altostratus clouds. These basically refer to a formless layer of grayish clouds that cover all or large portions of the sky. Generally, we can see the sun through altostratus clouds as a bright, diffuse-looking disk. Infrequent precipitation like light snow or drizzle may accompany these clouds. They're commonly associated with approaching warm fronts and may thicken into a dark gray layer of nimbostratus clouds, like we can kind of see here. Our next ones would be our altocumulus clouds. These tend to form in large patches composed of rounded masses or rolls that may not merge. Because they're generally composed of water droplets rather than ice crystals, the individual cells have more of a distinct outline. You can kind of see here and in these two photos. And then moving up to our high clouds, so heights greater than 6,000 meters. These are our typical ones. These are cirrus clouds. They're often composed of delicate ice filaments. Winds aloft often cause these to bend or curl, and these are often called mare's tails. Think of a horse, the tail of a mare. Kind of makes sense. We can see more examples of cirrus clouds here, that really typical shape here, there you go, our cirrus uncus, or our mare's tails, kind of very well shown in that bottom left image. Here, moving into our cirrostratus clouds, these are transparent whitish cloud veils with a fibrous or sometimes smooth appearance that may cover much or all of the sky. Remember, again, that stratus means sheets or layers. So we're thinking of high altitude clouds that are covering a bunch of the sky. These clouds are easily recognized when they produce optical effects, such as halos, as we see here, around the moon or the sun. Cirrocumulus clouds appear as white patches composed of small cells or ripples. They may be merged or separate and are often arranged in a pattern that resembles fish scales. As such, these are often called mackerel sky. While these are not precipitation makers, they can be a sign of stormy weather to come when cirrus clouds give way to cirrocumulus clouds. So the next question is, how and where do these clouds form? We see our dominant cloud types are cirrus, cirrostratus, cirrocumulus, our altostratus, altocumulus, nimbostratus, stratus, stratocumulus, cumulus, and cumulonimbus. So these are our dominant, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cloud types that we're going to want to know. So how and where do they form? You can see here, they form a lot of times as a result of what we talked about in our last video, localized or free convection. Kind of this example of localized forces causing buoyancy within our air parcel, and that buoyancy leading to condensation at the lifting condensation level, cloud formation. All these examples are what we would be looking at, going from kind of cumulus humilus to maybe cumulus mammatus, all the way up to cumulonimbus incus. Things like orographic lifting. Remember all these lifting mechanisms we talked about that drive the vertical motion of air parcels that lead to the development of clouds. Here we can see precipitation falling out as these air masses are forced up and over the mountains on both of these pictures here. And here we see this cloud formation as air is forced over these mountains. These are the same mountains in all four pictures. We're seeing the development from left to right and top to bottom of these bigger, broader precipitation systems. Frontal systems also play a big role. So here you can see as this front is moving into the warm air mass, we're seeing the development of cumulonimbus clouds on that leading edge. These bigger clouds that form as a result of the steep gradient of a cold front moving into a warm air mass. We see that here. And if we watch this cold front line here, we're seeing that development of clouds occurring quite rapidly as it's moving across Iowa, Kansas, Minnesota, and Wisconsin in our graphic here. It's what we call a squall line. So this rapid development of clouds on the leading edge of this cold front, we call these a squall line. Horizontal convergence is another one that we talked about, right? So cloud formation is a result of these low pressure cells and rising air from the surface, diverging air aloft. So as that rising air from the surface cools, as it kind of flows horizontally across the surface, it rises up, cools down, we have the development of these different types of systems here, for example, hurricanes or cyclones. These can be quite massive. This is Hurricane Jose from the International Space Station in September of 2017. One location along our world is quite famous for having cloud formation nearly all points of the year. That would be the intertropical convergence zone. Think of the Hadley cell cycles again that we talked about before, and where those low pressure systems prevail. The ITCZ or intertropical convergence zone, pardon me, I'm mixing my words up today, is nearly always covered in these big cloud types, right? These cumulonimbus or cumulomammatus clouds as we see them across our equatorial zone in this graphic here. They look like this. That's the intertropical convergence zone you're looking at ahead of you right now. These big cloud formations that are occurring as a result of these low pressure systems along the equatorial regions. You see them leading to some pretty significant rainfall across the region. Think of our tropics, where the majority of our rainfall occurs and across the world is in these tropical regions, these equatorial regions, where the intertropical convergence zone is. These pressure systems have set up, these Hadley cell systems have set up, leading to this prevailing development of clouds and precipitation. We see here in this example of warm front, so this warm parcel of air moving over this wedge of cold air. The further you move up, we see this more general transition from stratus or nimbostratus clouds to altostratus, cirrostratus, and cirrus, kind of as you move up in the altitude. So you might have gentle rain in the stratus or nimbostratus area, but you kind of lose that as that air is forced further up and cools down more and rises further into the atmosphere. You can see in these photos here, so I'm moving from our nimbostratus on the left to maybe our altostratus to our cirrostratus on the right, kind of where my picture is. You see that haloing effect around the sun above my video. There you go. You can see one last big image here. This is our incus cloud here, our anvil cloud forming as a result of a bunch of different processes going on. One more cloud type that is, I believe, recognized, but not necessarily what I would call great. So get on here. There you go. Contrails. They're everywhere. You recall watching the dimming the sun video, which I believe you've done by now. Contrails play a big role on things like our global energy budgets, temperature on the surface of our planet, and they add a lot of moisture and things like that to the atmosphere. So they are, I believe, recognized officially as a cloud type. So, quick recap. In this video, we talked about major cloud types, major cloud heights, classifications of clouds, and how they form. So in the next video, we'll be talking about precipitation. I hope you enjoyed this one, and I'll see you in the next video. Thank you.